Good morning everyone, this is Nagarjuna, Department of Research Officer, Varman College Engineering. Today I am going to explain how the diode acts as a switch. So actually in the previous reflections for many of the students asked me the doubts about how the diode acts as a switch. So that is the reason I'm cutting this video. So now let us see this how that diode acts as a switch. So in these two cases there are the two biasing conditions for the diode. So that is the forward bias and the second one is the reverse bias. In the forward bias the directions are these. So that is short what with the standard formula for the forward bias is like this. And if you make it the reverse bias, so it is the equivalent circuit for the reverse bias. So okay, so if it is forward bias, it will act as short circuit. If it is reverse bias, it acts as an open circuit. So now piecewise linear characteristics are nothing but, so this is if you go for the practical scenario, there will be some slight modifications between the ideal case and practical case. So these are the, suppose if the RF is nothing but forward resistance, if it is zero like this, uh, zero, if it is zero, so this is the diode, this is the ideal diode, and this is the cutting voltage of internal structure of this diode. So if it is reverse biased, and this is the VI characteristics. With a finite RF means there is some little bit RF resistance in terms of ohms. So this is the equivalent resistance. So this is in reverse bias acts as open circuit, and these are the characteristics of that finite RF. So actually this is nothing but what we call piecewise linear, and this is the ideal. Okay. Now, so now let us, this is the thing. So now let us go to the reflections part one. Determine the peak of the both amp half cycles of the output waveform. So now options are 16 volts minus 4 volts, 16 volts 4 volts minus 16 volts 4 volts minus 16 minus 4 volts. So now let us see. So if you apply the positive peak and negative peak, as we know that it is seen that positive peak you are applying, so we are applying the positive here. If you apply the, this is the negative HL. If you apply the positive peak here, what happens is, and it acts as a reverse biased. If it is reverse biased, the output is equal to input. So for the positive, entire positive cycle, so V naught is equal to VA. Okay. So positive cycle, so V naught is equal to VI for positive cycle. Now, if I apply the reverse bias, so minus 4 like that, my minus 1, minus 2, minus 3, minus 4, and so on like that. So till less than this minus 4, this acts as open circuit, and if I apply more than that is nothing but what we call so my minus 5, minus 6, and so on. So that becomes V naught is equal to minus 4 curve. So V naught is equal to, that is a fix, and for the minus 4 volts, and this is equal to V naught is equal to, this is 16 volts like this for positive peak, and this is what negative peak here. Okay, so the option is, the correct answer is 16 volts and minus 4 volts. This is the correct answer. And coming to the diode switching times, so in the diode switching times there are the two parts, the two definitions, the mainly characteristics of when forward bias is applied. So positive to positive, negative to negative. So there is some deflection region is happened at the junction. So there is some imbalance process. So in this case, it acts as some short circuit. So to make the junction, it will take some time. The time is we call it as a switching times. In that there are the two types, that is a forward recovery time and reverse recovery time. When the forward bias is applied, the time taken by the diode current reverse and attain a steady state value, it is very small in practical. It does not create any switches. That is the time taken by that time taken by the diode current. So to attain some steady value when the forward bias is applied, so the time is called forward recovery time. Reverse recovery time is nothing but when you apply the reverse bias, so but it doesn't change from the reverse bias to forward bias. It takes some time. So to come back from the forward to reverse, so that time we call it as the reverse recovery time. Okay. Next, and these are the characteristics of apply the positive and positive strikes acts as if the forward bias and acts as a short circuit. If you apply the negative, it is open circuit. And the till time t1, so this is the explanation of that. And so the total time, so the reverse recovery time is nothing but that we call it as a storage time and transition time. And so these are the waveforms of that. and come the total time is t is equal to practically t is equal to NTRR, so F max is 1 by t, and this is the one. And the reflection for the delay in which between on and off states is due to. So the delay between on and off, the time required change amount of excess minus charge per stored in quasi-neutral region. The time required to change amount of excess minus current stored in quasi-neutral stage. The connection between storage time and recovery time. The exponential in carried sense. So as we discussed earlier, and the answer is option A. So these are the questions raised by my our student at the time of the previous subject, previous video which I uploaded in the WordPress. So I would like to clarify the doubts. This is my explanation, and thank you.